Alrighty, so we are going into lesson unit 3-7. Lesson 7 of this unit, congruent triangles by ASA, AAS, and HL. And here's what is meant by each one of those. Last week we did SSS and we did SAS, and now we're moving on to 3 new ones today. Alright, so let's go ahead and take this due now. Go ahead and push pause, take a minute. Go ahead and go through this. If you already did it in class, then you can just skip over this part. So I know I have 180 degrees inside of this. Every triangle has 180, of course. I'm going to add up all angles, A plus B plus C. Okay, so it should look something like this. All right, let's go ahead and move on. So today we're going to be proving triangles congruent, just kind of like we did last week, again with the SSS and the SAS, but we'll be learning 3 new ones. We're going to be learning the ASA version, AAS postulate, and the HL, which stands for hypotenuse leg postulate. And I'm going to go ahead and take each one of these individually. So each slide, the next 3 slides will have each one of these by itself. So let's take the first one, ASA. If 2 angles and the included side of one triangle are equal to the corresponding angles and side of another triangle, then the 2 triangles are congruent. So let's take this first part here. It says if 2 angles, right? So let's assume this angle here, and let's just go ahead and say this one here, right? And the included side, this is very important, the included side. That means the side is in between those 2 angles, right? So let's go ahead and replicate that over here, right? These 2, of course, triangles would be congruent, right? So there would be definitely congruence here. So this triangle is congruent to that one. Okay, based on ASA, angle, included side, angle. Okay, so angle, side, angle. Okay, that's how it works. And make sure that this is an included side. It's really important. I'm going to keep emphasizing that because there is such thing now as a non-included side, which we'll talk about now. So if 2 angles and the non-included side, and we're here on AAS, the new one, all right, so if 2 angles and the non-included side of one triangle are equal to another, then they're both congruent. So look at this one here. So let's say I have 2 angles, here and here. And the non-included side, okay, really important here, non-included side could be here or here. I'll just make it there. I'll just make it here. Okay, so this is a non-included side. That means it does not fall in between the 2 angles. So let's go ahead and replicate that over here, and then again, this is an included angle. That's not what it's supposed to be. It's supposed to be a non-included angle. So I'll just put it there, for example. And then this, of course, would be AAS. Okay, so this would be AAS. And that is this postulate here, angle, side, angle, side, non-included side. So important, non-included. Okay, the next one, or the last one we'll be talking about today, the third one I should say, is the hypotenuse leg postulate. And what this basically is saying is that if a hypotenuse and one leg of a right triangle, remember, a hypotenuse only exists in right triangles. Okay, so only right triangles. So we're going to assume that this, of course, is a right angle. Okay, so the hypotenuse and one leg. So again, the hypotenuse is the longest side, so that would be this one here. Okay, so I'm going to say that's my hypotenuse, right? And one leg, so it doesn't matter which one it is. So I can do this one or I can do this one, but not both. So I'm going to say that's going to be the shorter one. If this is the case, then we would have congruence in these 2 triangles by the H, hypotenuse, leg postulate. Okay, so we would use a hypotenuse, leg postulate. Let's make it a little cleaner here. Okay, so HL. Alrighty, let's go ahead and do some practice here. I wanted to include this slide again. I'm not going to go over it on this one here. We did do it a couple times last week, but just remember that the definition of a midpoint we talked about, reflexive property, where basically a side is congruent to itself. Of course, anytime something is given, you just take it as true. Vertical angles we talked about, remember those are always congruent. Alternate interior, alternate exterior, and corresponding angles. This is the most important part here, is that these 3 here must have parallel lines in order to be formed. Okay, and then a definition of an angle bisector, we went over that as well. Basically, a bisector will create two congruent angles. It cuts an angle in half, or in two equal parts. All right, so let's go ahead and take a my turn here. The first one here that I'm going through, right off the bat, I'm like, oh, there's a right angle for sure, so I'm maybe using HL, but for whatever reason, I want to identify, of course, that this is a right triangle first off, which means that this side over here, these sides are your hypotenuses, right? Hypotenuse. This means your hypotenuse over here. Okay, and then I want to also emphasize that a leg. So I'm told that hypotenuses are equal in both triangles, but I'm not told anything about a leg. So I have to take some knowledge of my own and understand, oh, hold on. This guy right here is equal to itself, I should say, right? Which means that this congruence, this side that is congruent to itself, is because of the reflexive property. Okay, the reflexive property tells me that this here, this leg is congruent to itself, so I do have a leg, right? This will be my leg then. I have a hypotenuse. We'd be doing the HL postulate on this one. All right, let's go to the next one. So let's go ahead and take this your turn here. I'll go ahead and do it with you, of course. So you have an angle, okay? I have a side, but that's all I'm given. So I have an angle, I have a side, but I do know one thing. We have to pull some old knowledge out. We know from Unit 1 that when two lines intersect like this, right, the angles formed here and here, right, so they're called vertical angles. And vertical angles, we know, are congruent. So in fact, we do have angle, side, angle. Okay, so this would be an ASA, and we see the other triangle also has the exact dimensions. So we have congruency by ASA. All righty, let's go on. So my turn. For what values of x and y? I also want to point out that this here, remember, is an included side, right? So this here is included. It's an included side. Very important with ASA, it must be included. Okay, so I kind of messed up on this, so I'm going to kind of include all these slides in one. Let's do the your turn part here. So I'm right here. So when I'm looking at this one here, I see I have angles over here, so I have angle, angle, and you notice that because of the reflexive property, this side basically is congruent to itself, so it is an included side. In this particular case, I would have an angle, side, angle. All right, let's go ahead and take this one here, the my turn version over here. When I'm going through this here, again, I see an angle. Okay, so there's an angle here. Okay, there's a side here. And I realize that these here are congruent because they're vertical angles, right? So those are verticals, right? So those are the, vertical angles, so those are also congruent. So in essence, then I have and realize too that it is a non-included side, right? The side does not fall here in between the angles, right? It falls over here. Right, so this is a non-included. So remember, that's non-included. Right, we know from our notes that this would then be an AAS, right? Angle, angle, side. And that side, of course, is not included. All right, let's go ahead and take this last portion over here, or my turn. For what values of x and y are the triangles congruent by the HL theorem? We're actually told to use the HL theorem, so that helps. So we know we have a right triangle. We're going to match up the hypotenuse and a leg. So first and foremost, I know that this here, these two here are my hypotenuse. So in order to solve for x, I can just set 2x plus 1 equal to x plus 3. Okay, so I'll do minus x, minus 1 both sides, minus 1 both sides, that goes away, and I'm left with 2x minus x. Well, there you go, x equals 3 minus 1, 2. Now I'm going to use this and I'm going to go ahead and say, well, these two legs are also equal. So I'll say x plus y equals 3 times x minus 3y. But we know that x equals 2, so we're going to go ahead and substitute our 2 value, right, here and here. Okay, so at this point then, I will just add 3y both sides because I want to keep it positive. Okay, and I'll minus 2 from both sides. Okay, subtract 2 from both sides, and now I'm left with 4y equals 3 times 2 is 6, and 6 minus 2 is 4. Go ahead and divide both sides by 4. Okay, and now I'm left with y equals 1. And I have done exactly what I was told to find the values of x and y. Okay, let's try your turn. Go ahead and push pause and then see what you got. Okay, so after a few minutes of trying this here, you should also see that you have a HL theorem going on here because I have a lag and a hypotenuse that are congruent to one another. Okay, so I'll take these pieces first and I'll say, well, 2x plus 8 equals 10x. Then I want to go ahead and solve using your algebra. And you should get something like this, x equals 1. Okay, you can look at the algebra on how I did that if you did not get exactly what I did. Next piece, I'm going to go ahead and take this, kind of like the last one we did. I know that my x value is 1, so I'm going to use 1 instead of x. So I'll say y plus 2 times 1, right, equals 10 times 1 minus y. So let's go ahead and simplify that a bit. And your algebra should look something like this. Okay, so then we see that x equals 1 and y equals 4. Answer choice A. Alrighty, so you will go through these independent practice here on your own. Determine whether or not the following sets of triangles are congruent. If they are congruent, state what postulate is used. Okay, you notice that the new ones are ASA, AAS, and HL, and these two, of course, are from last week. So you have 5 postulates. You'll have to use your notes and your knowledge of these postulates in order to get through these problems. Shouldn't be too challenging, though. I expect questions, if you do have them, to be directed my way. You'll go through 1, 2, 3, 4, 5, 6, 7, 8. You'll do a review on lesson 3-2, which is about 5 lessons ago. Okay? Then you'll finish your exit ticket. And that's all for today. Thank you all very much. Have a great day. And good luck. If you have any questions, I do expect you to reach out to me. All right.